Now we'll start about dihalogen derivative. Now dihalogen derivative is this compound is called as ethane. If you replace two hydrogen atom of an ethane by two halogen atom, you will get dihalogen derivative of ethane. Now, depend upon which hydrogen atom you are removing by halogen atoms, you will get two types of this. If I remove the two hydrogen atom of a same carbon atom, I will get something like this. And if I remove two hydrogen atom of a adjacent, one from this and one from this, I will get another compound. Now both these compounds are dihalogen derivative of alkane only. Let's name this compound. This is ethane. Now IUPAC name is very simple. This is called as 1,1 dichloro ethane, while this compound is called as 1,2 dichloroethane. Now, in the first compound, both halogen atoms are attached to a same carbon atom. This kind of a halogen derivative of an alkane are called as geminal dihalide, while compounds in which both the halogen atoms are attached to adjacent carbon atom is called as vicinal dihalide. So in geminal dihalide, halogen atom attached to a same carbon atom. In vicinal dihalide, halogen atom attached to a neighbor carbon atom, adjacent carbon atom. Now, what is common name of this? Now, generally, the common name of geminal dihalide, it is written by alkylidene. Alkylidene dihalide. Alkylidene halide. While general name for vicinal dihalide is, it is alkaline. Alkaline dihalide. For example, if you want to write the common name from this 1,1 dichloroethane, this is two carbon atoms, so we will write here ethylene, ethylidene chloride. While common name for 1,2 dichloroethane is, this is ethylene dichloride. Now, one of the very important point in this two compound is this. Here when you used to write this alkylidene, you have tried only halide, alkylidene halide, because the two valencies of this carbon atoms are satisfied by the same halogen atom. Where you are using what? A dihalide, that is ethylene dichloride. So ethylene dichloride, this is ethylene chloride is. This is the important difference between this geminal and vicinal dihalide. So this is called as dihalogen derivative of an alkane. After this, you are going to start with the next one. Now the third classification, nature of bond between carbon and halogen. Now before going to start this, always remember, whenever any carbon atom form four covalent bond, meaning is this carbon atom undergoes sp3 hybridization. If any carbon atom forming a double bond with another carbon atom, meaning is this carbon atom is under the sp2 hybridization. If any carbon atom is forming a triple covalent bond, meaning is this carbon atom is under what? sp hybridization. So very important point is, so carbon atom 4 covalent single covalent bond, sp3 hybridization, carbon atom double covalent bond, sp2 hybridization, while carbon triple covalent bond, sp hybridization. So depend upon now nature of bond between carbon and halogen, we are going to classify this halogen derivative. Let's start with this. Now the first classification is, it's called as alkyl halide. In division lecture, we already seen alkyl halide. Let us see 2-4 example of this. This is called as methyl chloride. If I replace chlorine by another bromine atom, then you will get methyl bromide. Another example is, this is called as N-propyl chloride. So this is what called as alkyl halide groups. The second classification is called as benzyl halide. And benzyl halide, what is a benzyl halide is? This group or this compound is called as a benzene. If I just draw this, this is called as a phenyl, and if I write here CH2 dash, this compound or this group is called as benzyl group. Now, if I write here halogen atom, then this is called as benzyl halide. Now, one of the very important thing is, if you look for this carbon atom undergoes sp3 hybridization. This carbon atom under also sp3 hybridized carbon atom. So, in this case and both these cases, halogen atom is attached to carbon atom which is sp3 hybridized. We will write one other example for this if you want. This is benzyl chloride. This is benzyl bromide. And we will see another compound. The same way in alkyl halide and benzyl halide, the halogen atom attached to a carbon atom is sp3 hybridized. In another form also called as allyl halide. Now, in allyl halide also, the halogen atom attached to the carbon atom which is sp3 hybridized. Which is this. In this case, halogen atom attached to the carbon atom which is also sp3 hybridized. This group is called as allyl group. This group is called as allyl group. If I replace this X by chlorine bromine, let us see what will happen. You will get different kind of compounds. CH2, CH single bond, CH2Cl. This is called as allyl chloride. Or another compound is CH2, CH2 bromine. This is called as allyl bromide. So in all this compound, you will find that halogen atom attached to the carbon atom which is sp3 hybridized. This is the one more compound in which halogen atom is attached to the carbon atom which is undergoes sp2 hybridized. It's a D which is called as vinyl halide. Now, which group is called as vinyl halide? CH2 double bond, CH single bond. This group is called as vinyl group. This is the example is CH2 double bond, CH single bond bromine. This is called as vinyl bromide. Another example, CH2 double bond, CHBr. This is called, instead of Br we will write Cl. This is called as vinyl chloride. Now in this case you will find bromine atom attached to the carbon atom which is sp2 hybridized. Which is sp2 hybridized. This is very important one. So in the first three, the halogen atom attached to the carbon atom which is sp3 hybridized. While in this case you will find this carbon atom is undergoes sp2 hybridized. So this is what depend upon nature of a bond between carbon and halogen atoms. It is classified into 4 types. Let us start with the next one is also after this vinyl. The next one is very simple one. This is it's called as haloarane. Now in haloarane, benzene. In this you will find halogen atom attached to the carbon atom. This carbon atom is sp2 hybridized. This is called as chlorobenzene. Let's start the next one. Again, this is chlorobenzene. In 11th science, we have seen a position. This position is called as ortho. This position is called as meta. And this position is called as para. How to remember this? I think I said this something like this, Om Prakash. Okay. So just try to recall that. Om Prakash. This is ortho position, meta position and para position. Now let's start with the example is, if any halogen atom if attached to this one, chlorine, then this is very simple. You have to number this. This is 1, 2. This is 1, 2. Dichlorobenzene. Another example is so number the compound first. This is 1, 2, 3 and this is 4. So we label as 1, 2, 4. This is called as trichlorobenzene. Just write one more example. Now what will be the common name for this? If you want a common name for this is ortho-dichlorobenzene. Similar way you can write many compounds. If you want to write more example is, this is, if you write a bromine, this is called as ortho-meta position. This is called as meta dibromobenzene. Para position. This is called ortho-meta and para. So this is para dibromobenzene. So depend upon nature of a bond. In this all this example, you will find that the halogen atom attached to the carbon atom, which is sp2 hybridized. This all the carbon atom in this case sp2 hybridized are. To start with the next one, it is called as haloalkyne. And haloalkyne, we know the example is HC triple bond CH, called as acetylene or ethine. Just replace hydrogen atom by chlorine. We will find this is called as chlorethine. In this case, carbon atom undergoes sp3 hybridization. I'm sorry, this is sp hybridized carbon atom. So this very classification we have seen depend upon nature of a bond between carbon and halogen atom. So first one is alkyl halide. After that we have seen vinyl halide, allyl halide, haloarine, benzyl group. Then the last one is haloalkyne. Now after this we are going to start with the nomenclature.